This is your presenter Asloob Mudassar, and I am presenting slide number 26 of the course on laser physics. Question is, how will you describe the field quantization of electromagnetic modes of a cavity? The answer is, let Ex and Ey are the transverse electric and magnetic components of an electromagnetic mode of a resonant cavity at a position r and time t. The energy of such a mode in terms of its components is given by E is equal to integral of rho dV, where rho is the energy density and dV is the volume element. Then the integral in terms of its energy components within the curly bracket is the average of half epsilon Ex square plus the average of half mu Hy square. So this will give you the energy of the mode, where V is the volume of the cavity. Like a mechanical oscillator, the modes of a cavity are also characterized by a resonance frequency nu, and the quantization rules of an electromagnetic oscillator are similar to that of the mechanical oscillator. That is, the cavity modes are quantized like that of the harmonic oscillator. The energy eigenvalues of cavity modes are given by E is equal to half h nu plus n h nu as given in equation 2, where half h nu is known as the 0 point energy, which exists even if n is equal to 0. For the moment, we assume that E is 0 in equation number 1. That is, in this equation, we are setting capital E on the left hand side to be 0, which implies that Ex is equal to 0 and Hy is equal to 0, but both cannot be 0 simultaneously, as it contradicts the Heisenberg uncertainty principle. Thus E cannot be 0. And you know that the Heisenberg principle is delta E into delta T of the order of h bar. So delta E is not required to be 0 in that case. And you know that we have plotted the energy levels of a cavity mode in this figure. You can see the 0 point energy, which is a half h nu, is there, and n is equal to 0 start from the level next to that one. Then we have n is equal to 0, n is equal to 1, n is equal to 2. These are the levels which are separated by an energy h nu. Apart from the 0 point energy, the equation 2, which equation? This equation. So apart from 0 point energy, the equation 2 is E is equal to nh nu, which is Planck's concept of quantization energy. It is assumed that the 0 point energy is linked with the electric and magnetic field fluctuations in a cavity. So this is the end of slide number 26.